2 years ago, I bought my first laser cutter, the xTool M1.
Oh, what an absolute beauty.
It's been fantastic for making custom tech projects, but when it came to making my custom desk, it couldn't cut the clear panels. Well, thanks to watching my vids and blowing up the projects, xTool reached out and have sent me their top of the line model, the xTool P2. There's been some quirks that I've had to work through, but I can't wait to show you what this can do compared to my old machine, the Holy Grail, but also how you would operate something like this for custom projects of your own. I did that at home. Almost perfect.
I'm kind of lost for words. Thank you for watching. I would have never been able to probably buy something like this on my own.
Here we go. Ah!
That piece there is not on properly.
Doesn't seem like these front screws bite into the plastic a lot, so could have just been knocked in shipping.
Yeah, that's holding. Sample acrylic. This is so freaking cool. Oi!
Dude.
What an absolute stunner.
This is a 55 watt CO2 laser tube, and it creates the invisible laser beam. But before we can fire it up, it requires water cooling. Now the instructions say to use purified water, but I think they actually mean distilled because you don't want any minerals. And then depending on the coldest temperature of where you live, you need to mix that water with antifreeze, which is also included in the box. Since my garage is insulated and doesn't go below zero, I'm going to use straight distilled water, but if you have a tin shed, it's definitely a consideration.
It's on for the first time. Dude, the tube! There's all these bubbles.
Now the included hose isn't very long, which is fine because I use a second exhaust fan, which is much larger and allows me to run all the way outside.
So now I can start cutting stuff. This is a piece of clear acrylic, right? Super see-through. 3mm transparent acrylic. All right, let's set that to cut and my logo to engrave. Start. You can see, look at engraving. Oh man. My heart is like, it's so happy. I'm so happy. And now for the grand finale. Oh, that is so special, man. Clear acrylic.
Why is that so special? So, my first laser cutter, the xTool M1. It's the most common type of hobbyist laser cutter you'll find. It's a diode laser. Now, this is like a blue laser pointer on steroids. The problem with the blue laser, it's 455 nanometers of wavelength. It's only able to be absorbed by certain materials. So, wood, great. I often use wood for prototyping, like the panels on the desk, or for a final product like bamboo plywood for the custom keyboard build. Something like this coaster is quite typical. It's got an etched surface, so you're only just taking the top layer off and then cut the circle for the outside. I made signs where I layer multiple types of wood for a contrasting look, and by layering multiple tiers of wood, I've made topographic maps, which are like a 3D terrain look. Woods are fantastic for these types of machines, but when you go to plastics like acrylic, it's a different story. Black, fine. I had a friend that ordered a wedding cake topper and it arrived wrong, so I whipped up a design and saved the day. But once you venture into colors with a blue laser, it's a different story. See, the lid is made out of dark orange tint because orange cancels out the blue and the visible light spectrum. So if you're looking at reds, oranges, yellows, browns, they're good. They'll cut, it'll be absorbed. But blue or a light color like white, it's going to either do nothing or struggle. So you have to do multiple passes and you end up with a very unclean cut. And the blue laser beam also passes straight through clear material. But the xTool P2, since it has a CO2 tube, produces a far infrared light at 10,600 nanometers wavelength. It's absorbed by clear material and all other colors of acrylic, which means I can now cut so many different colors that I never had before, especially at home.
Oh, this has to be the coolest. The light passing through is, I guess, the opposite. What, gold to blue, yellow to green. Changes color. All right, I'm gonna try etch 2 slats closer so I can sit that back on there. That is so bright, the edges. If you put like LEDs on the edge, it makes the etching glow. My favorite color, I can finally cut blue. I've got other blues as well. The holy grail, transparent blue. The two things I couldn't do combined. Now you might be thinking, how can you cut with that beam when it's at the back of the machine? Well, it has some mirrors. From a top-down view, the laser tube shoots its invisible beam out the end, hits a mirror, goes through a pass-through hole, hits another mirror, and then into the head, which if you looked front on actually has another mirror that bounces the beam down to then vaporize your material. If either of these mirrors aren't perfect, the laser beam will miss and end up just like pointing not where you want it to go. What surprises me is that the quick start guide has no mention of tuning the mirrors. It simply says to add the water, do the water cooling, to add an exhaust pipe, and then download the software. And once you've downloaded the software, you can start your creation after connecting them. If you need further help, go to the support page. Well, the support page will actually have a #1 article. And that article is how to test and calibrate the optical path for xTool P2. In brackets, important. Before starting the initial processing task, after you unbox and set up the P2, is instructed in the quick start guide to please test the optical path before use to ensure proper material processing. No, it's not in the quick start guide that I got. Thankfully, I knew that this is something that needs to be done, so I did it before I did any cuts. The thing is, when you run through the built-in guide, if either the first or second step of the process fails, you need to remove the rear cover that we just put back on after adding the water to then access the rear mirror. And I even had to look at their video guides to confirm that a second panel needs to be taken off, because when I went to do it on my machine, there were these red "don't remove screw" stickers. But it was only after removing those that I could actually access the rear mirror. To then heat up some glue on a locking screw so I could finally make some adjustments to my mirrors to make sure it was dialed in.
How's it now up? Doesn't make sense.
I've been going back and forth, making adjustments. The instructions are wrong. No wonder I see people in the forums complaining this is a complicated process. So how's that? I did the opposite of what the instructions said to do.
Absolute perfection. Only took a couple tries.
It was only the first pass-through hole that the instructions were wrong for, they were correct for the rest, and it was very helpful to have the click-through guide to match the results you got with the tape to what you could see on the screen, to then be told which bolts to turn and what direction. Bullseye, baby!
To test the accuracy, use the toothpick test. Now this built-in camera will capture a photo of the entire bed, but by selecting capture close view, a second camera attached to the head takes an even better photo that we can zoom right into for pinpoint precision. Now I should be able to type something here. Oh no, the air blew it out of the way. I generally thought nothing happened, but then it's so small. Oh man, dude, as I roll it, you can see the depth of the etching of the letters. That's crazy. That is so small.
Okay, so by now you're probably thinking, is it complicated to control a machine like this? Yeah, like what type of software do you need? Is it hard to use? We got two options. There's Lightburn, which is around $100 Australian for a license to get updates for a year. Big fan favorite when it comes to laser cutters. Or you can use xTool's own Creative Space software, which is free and has direct integration for all of their add-ons and features for their machine. So I prefer to use Creative Space software, and it's come a long way over the past 2 years of me using it. Now, you can import two types of images. You got bitmap, which is like a photo, JPEG compression with, pixels, or vector images, which is like code. It's essentially dots with lines connecting them. The benefit of vector graphics is the laser can simply follow that line or color in between them. And the benefit of Creative Space is it's got vector editing built in. So you can make rectangles, circles, multiple shapes, type in some text. You can group, align, combine, and subtract vector paths from one another and type in specific measurements or even a quarter radius to round a rectangle. And those tools may be all you need to be able to make the stuff that you want to make. But for me, I use Inkscape, which is a vector editing based software like Illustrator, but it's free. And in my graphics, I make my cut lines red and my engraved sections black. So when I import them into Creative Space, I can go to the bottom left, select all red paths, tell it that I want it to cut, select all black paths, tell it that I want it to engrave, and now simply select the material I'm using to preload the power and speed for each operation.
Now I connected the device via USB, Wi-Fi, or Ethernet. Not all laser cutters have network connectivity, which if you have a laptop isn't a problem, but I'll be going back to a desktop PC soon, which will be at the opposite end of the house. So it would be an issue if I had to USB connect to the laser cutter. After connecting, it takes a photo of the workspace area, which can process materials up to 600 by 308 millimeters. I hit process, sends a job to the laser cutter, I press the big silver button to start the job, and then I get a progress bar on the screen. And that's it. Like if there's any issues, you can manually tweak the cut and engrave settings for your specific material. Sometimes it doesn't match the material presets. It's so much easier than 3D printing and CNC because it's just a 2D operation. You can get more fancy and go laser cylindrical with the rotary tool attachment. This allows you to load glasses and bottles to rotate objects as it engraves. Or if you buy the conveyor feeder attachment, you can put really long pieces of material through and like make huge signs, a whole table design. I did see there's a curve process beta feature, which I tested out on a lid of a jar. It uses the autofocus's laser distance sensor to 3D map the object. The first try, it froze the machine. The second time it missed the top of the lid. So after some tweaking, I finally got a nice perfect curve. It did the engraving and varied the focus of the beam as it went, but it does limit the engraving to 100 millimeters a second speed, which I presume is the speed that the autofocus module can actually move up and down. So it resulted in quite a deep burn of this wood at 1% power. And it also doesn't seem to warp the graphic around the curve. So when it's viewed off axis, it has a distortion on the object. But it does seem this feature is intended for a curved surface like a bowl. And if I wanted to do a cylinder, I should just buy that rotary tool to get a better result. But now that I have this powerful laser at home, there's something that I want to try that I haven't done before. On the final panel of my desk project, I had to hand grind down a pocket for a part of a circuit board to push into. And so I had a thought, what if I engraved really deep? Well, it seems the dust gets caught in the groove and remelts back into the material. So I took some clamps I included in the box to hold the material in place. By setting a general engraved depth setting, I could then just wipe away the dust and repeat the process. After some testing of engraving, wiping, I finally had an engraved depth deep enough to slot the circuit board into. All I had to do now was dial in the engraving settings, which for this frosted acrylic at the 600 millimeters per second max speed wasn't very accurate. The industrial machine that I take my jobs to is 10 times the price, so it's no doubt going to be the best, but I reckon the P2 can do better. So the 600 millimeters a second is inaccurate, but 500 was a big improvement. And at 15% power, 200 millimeters a second speed, and 300 lines per centimeter, I hit a sweet spot for this frosted acrylic. And so from the box of desk parts, I fished out my backup panel and fired up the machine. At first it's going to engrave, etching away at the top surface, and then it's going to cut out all of the pass-through and mounting holes. I can now flip over the panel, and by using that close view camera, perfectly place the engraving section for the rear circuit board slot. Wiping and scraping away any excess dust over and over and over again until eventually
1.8. That should be enough. It's a perfect fit.
The only problem is when I was cleaning the panel, I noticed some marks that wouldn't come off. See those flashes of light? That's the laser beam hitting a metal slab. Now, normally this heat isn't an issue, but it is if one of your cut lines is directly along a slat. What are the chances? Oh well, I'm just gonna put it back together, get it back in the desk, and at least it looks a lot crisper and cleaner than it did before. Yes. With some lines.
Okay, so before I go over the pricing of my old machine and the new one, I just want to quickly cover safety with lasers because they're not all created equal and you need to protect your eyes and your lungs. So, enclosure. 100% make sure that whatever you get is enclosed. This way fumes can be extracted out of an exhaust pipe. Now I loved seeing in the included printed manual to not cut vinyl or PVC based plastics, which when vaporized by a laser creates chlorine gas, which you do not want to create. The other benefit of an enclosure is turning the class 4 laser that can do damage to your eyes into a class 1 by having a laser shield that should block all of the radiation from coming through into your eyes. Open machines ship with glasses, which can still have gaps and don't protect pets or anyone else walking into the room during operation. To me, never worth the risk, so I'll only ever use enclosed machines. The only criticism is that the riser attachment opens up the front of the machine, turning into a class 4 laser. This is specified in all of the documentation, but in all of their promotional material, the actors aren't wearing glasses. I understand the laser's not actively running in those ads, but they should show someone wearing glasses, as I don't include glasses with that attachment, and I've seen YouTube videos of that attachment of people aren't wearing glasses. And there's a big hole at the front of the machine. And I'd also like to see the emergency stop button not almost flush at the back of the machine, so you have to reach over to hit it if it's on fire or something's gone wrong, and instead at the front, so I can just easily access it and slap it down. But overall, I've really enjoyed using the machine. The solid metal handle is a nice touch, and the gas lift struts so that the lid doesn't slam down on you is also quite nice. Now for some pricing. I'm gonna start at the bottom and work our way up through the range and mention standout features. So if you're looking at other makes, models, you can compare and go, oh, that's what Cam said. This one costs more because of that. The M1 that I bought 2 years ago is a 10-watt diode machine. So it's got two 5-watt lasers joined together. 1,359 Australian dollars. Great first machine, but it doesn't include air assist. So if you want cleaner cuts on wood, you need to buy that module separately. I bought it for around $200, I think. And being an enclosed laser cutter with autofocus, I'd have no hesitation buying it again. It also has a blade cutter attachment, so you can cut custom stickers, vinyl, iron-on, that's how I make my shirts. If you need a slightly bigger workspace, there is the xTool S1. There is a 20-watt model for 2,589 Australian, 40-watt diode for 3,499 Australian. I was actually joking with an engineer when I worked at the uni about how many 5-watt diodes they'll be adding. They just keep going up. There's companies now doing 60 watts. I'm sure xTool will do one soon. The S1 has integrated air assist and that 3D mesh mapping by a pro. There's also a laser crosshair for precise placement. And then we're at the top, the xTool P2, 55 watt CO2 invisible infrared laser machine. 6,499 Australian dollars. Yeah, now you know why I was so stoked at the start of this video.
I'm kind of lost for words.
Now, there are plenty of cheaper CO2 machines out there. Some require a bucket because they don't have integrated water cooling loop, or they have a smaller workspace area, can't use attachments, or don't have Wi-Fi, so you have to have a computer in the room. And there's plenty that are way more expensive and more powerful, like the one that cut the desk. $70,000 machine, it's industrial grade. The P2 has stuck out to me because although it's at that hobbyist level, it has autofocus and air assist and all these new features that you want. If you're planning on buying a CO2 machine, be aware that those tubes are a consumable. This one's rated for 6,000 to 8,000 hours, and it's $1,000 to replace after that. There is maintenance like flushing and replacing the water coolant, especially if you're using antifreeze, and cleaning the mirrors because the laser is at the back opposed to on the head like a diode machine. And with a typical diode machine having a 20,000 hour diode lifespan and being far cheaper, they're a great option. But if you want to cut transparent materials and any color, man, CO2 is the way to go. And I'm so grateful that I now have my own machine, and I'm excited to share the future projects that I'm working on, like the custom PC build, using it. Thank you for watching. If you liked today's video, thumbs it. If you loved it, sub it, and I'll see you in the next one.